In this tutorial, we'll talk about the class cluster analysis software tool and learn how we can generate this type of very visually appealing publication quality images for various our studies. Alright, class is a free software we can access from Max Planck Institute website. So just type class cluster analysis, and here we have the link for MPI Bioinformatics Toolkit. Click on the link, and here the website contains several useful bioinformatics tools. What we want is the class analysis. So click on the class, and that will pop up this window with a space for the pasting of required sequences. Here we can go maximum up to 10,000 sequences in FASTA format, and I have checked that there is an upper limit for the length of sequences. Maximum about 20,000 individual amino acids can be put for a single analysis. So for this tutorial purpose, I have downloaded a set of protein sequences from NCBI database. In this folder, I have a list of endolysins collected from bacteriophage genomes. So all are in the FASTA format, and make sure that none of the labels or headings are repeating among sequences. Alright, let's go back to the interface, and here we have the link for upload file. Click on the upload file and select our the FASTA file that is going to analyze through the clustering, and click on the submit button. This will take a few moments depending on the server traffic, and after the analysis is completed, we will get few links to download the zip file that contain the results and the appropriate class jar software application for visualization of our result. So we have to click on both, download the result file and the class jar file. Okay, let's check in the download folder. Here I have this result file and the class jar file. Both I will cut and paste onto my previous folder I have created for the analysis. So the result file we have to unzip. We will extract in the same location. Right, we'll close the extractor. Okay, now I do not need the zip file, so I'll just delete it. And the class application is a Java application, so even though it represents as a zip folder, we do not have to unzip this particular file. Right, first to initiate the application, we have to go to the command prompt, cut in the search section, check in the search section and type cmd and click enter. That will bring the Windows command prompt, and here we have to locate the file that we just created, that which contain the result file and the class jar file. So we will navigate to a particular folder using the cd command or change directory command. Type cd desktop, click enter, type cd class test2, that is my folder. Click enter. Now inside this folder we have to type java the stroke xmx4g stroke jar clans jar this command. So just copy it from the web interface and paste inside the command prompt and just click enter. That will pop up the graphical user interface. So we can load our result by going to the file section and selecting the load run and select our result file, click on the file name and press open. Now as you see here, each individual sequence is represented by a single dot here. So by using this panel we can add numbers representing each of the sequence. If you want, we can add the names too, but it will make a mess since the names are too long. So I will just unclick it and I can show the connection by clicking on the connection button, and let's start run. So by default, during the analysis, that the analysis has already occurred and 53,000 rounds has already been calculated. So let's resume the calculation and see each point in the three-dimensional space is subjected to some sort of attraction and repulsion forces, and they separate and cluster based on their blast similarity. So each of these lines represents the blast connection, and the intensity of these lines resembles the intensity of the blast score, how strong the relationship is. And if there is no significant similarity between each clusters, there will be no connection between them. So once we run the software, we can see after certain threshold rounds there will be no more separation. So at that point we can stop the analysis and we can investigate what type of interactions have created during the analysis. Since this is in the 3D space, we can orient to visualize our preferred groups for our analysis. If we want to visualize all the member sequences in a list, we can select all and select show selected, and that will populate the complete list. Here I have 59 individual sequences. If I want to identify a particular sequence or several sequences, I can click on the required sequences and press OK. And if you go to the graphical user interface, we can see that those sequences are highlighted here. So it will be easy to spot our query sequence based on our preference. Right. Then we can do a little bit of manipulations if we want. For example, if I want to identify what are the sequences clustered in this particular cluster, I can click on the select or move button and click on that particular cluster and click on the show selected. So here we have the list of the sequences that belong to this particular cluster. Let's clear all, and assume that if I want to highlight these nodes in blue, what I have to do is select the particular cluster and go to Windows, click on the edit groups and add selected, and we'll specify a name, let's say T1, and click OK. And by clicking here I can change the color. So let's select blue. Now if I click on this one, it will appear in blue color. At the same time, if I want to demarcate these nodes in a different color, similarly I have to add a name, let's say T2 at this time, and we can select T2 and specify the color. By default it is red, and let's click update. Likewise, we can add colors or change the shape of these nodes, and a lot of manipulations we can implement. Alright, so once we are done with the cosmetic works, and we have to export the file, but unfortunately this graphical user interface does not contain image export function. So as a result, we can do the print screen option on the keyboard. Just do the screen capture by pressing the print screen button that is located at the right hand side of your keyboard, right top corner of your keyboard. Click on this link and we can use an appropriate software to save it. Just paste it. So we can crop as necessary and save this image for to do our further analysis with the software. Alright, now so this is an example with the protein sequences. If I want to do the similar kind of analysis for nucleotide sequences, we can do it in a similar fashion. Assume I have a relatively large number of sequences that exceed in the limit that is given by the web interface. We can run it in a local machine using the older version of the class software. So here I have the older version of the class and older version of the BLAST engine, and 84 complete file genomes. First I have to double click on the BLAST software. It will automatically add 3 different folders named bin, data, and doc folders. The remaining tasks we will conduct in the CMD, the command prompt, as we did it earlier. So similarly, we have to go to desktop. We have to go to locate the folder, the class test, click enter, and as before, we can evoke the software by typing the command. It will pop up the graphical user interface. At this point, I have to turn off the software and go to the command line one more time. And at this point, we have to add a little bit longer the command to execute our algorithm. Make sure that the name of the raster file resembles whatever the name you put to your the file here. So here my file name is 84 pages, and I replace name position with 84 page .raster name, and I will clear copy the entire the command and paste here, and just click run, and it will initiate to run the local BLAST in your local machine. And what it will does is do the BLAST all against all by taking individual sequence. So it has to cover all 84 sequences, and it will take some time based on the speed of your machine. So let's wait until it completes all 84 sequences. through the blast analysis. Now the analysis has been completed by running the BLAST algorithm. Let's see the kind of results we can obtain here. Now all the 84 sequences are scattered and represented by tiny dots, and as before we can visualize the numbers, and if we want we can click on the connections and start run. Let's see how the sequence is going to cluster. So we can wait until the separation is completely stopped or plateaued. At this point I would run this about 5,000 or 10,000 rounds and see when there is no more separation of this each point. And here the thick black color lines indicate the very high BLAST score, and the cluster has a very good relationship among each member. And sequence has been clustered into major 3 clusters and few scattered sequences. So we'll wait until it run at least about 5,000 rounds during the analysis. When you see there is no more separation, you can stop the run. Now you can arrange the orientation for your preferences. Once the analysis is done, as we did before, we can do the screen capture and save the figure for further analysis. This is the end of the tutorial. I hope you have enjoyed it. Thank you.